this is the first question in the section, and as a result it's fairly straightforward. We're going to have phosphorus burning spontaneously in air to produce tetraphosphorus decaoxide. So we have 4 phosphoruses, 5 oxygens to give us P4O10. We're going to find first off, we're going to find the enthalpy of combustion. So that is going to be the delta H for the overall reaction. And then we're going to find the molar enthalpy of combustion for phosphorus. Okay. Now, this reaction is set up quite nicely for us. You'll notice that the reaction arrows are lined up almost perfectly vertically. You're going to try and do that every single time, but when you see them written in textbooks and on tests, it's very difficult to have that typeset properly, so they're going to be offset just a little bit. Another thing that you'll notice is that the P4O6 is produced in the first step, and then it's consumed later on, which means it's a reaction intermediate, if you recall that from back in September and October, which means when we find the overall reaction, it actually cancels out. And we have the 3 oxygens and the 2 oxygens that don't cancel out. So we have 4 phosphoruses and 5 oxygens, and this is going to turn into P4O10. And our enthalpies are just going to add. So we're going to figure out what the total enthalpy change is, and that's going to be negative 2,984 kilojoules per mole. Now that's how much enthalpy we get if we burn 4 phosphoruses. So how much are we going to get if we burn only 1? Well, we take our negative 2,984 kilojoules for every mole, and we're going to figure out what happens when we divide it by 4 phosphoruses. So we have 2,984 divided by 4, and that gives us negative 746 kilojoules for every mole of phosphorus.